हेलो एवरीवन। मैं जॉब नहीं दिलवा रहा तो जस्ट इन केस, बट आई एम Barun Acharya. Hopefully good tea and coffee break session. I'll talk about patch it up, real-time vulnerability management with Kyverno and KubeArmor. Again, lot of keywords, but I had a good privilege that my session is so late. Lot of good introductions from the morning. I don't need to cover a lot of things. But I'll start with my introduction. Who am I? So I maintain a CNCF project called KubeArmor, hence the plug in the talk. I lead the open source team at Accuknox. It's the vendor company for KubeArmor. I am associated with Google Summer of Code, Linux Foundation Mentorship, both as a mentee and a mentor. I'm a proud CNCF Ambassador. I'm volunteering at this CNCG New Delhi group, and I help organize events as part of CNCG KubeArmor. So that's about me. Let's come to the crux of the talk. That's vulnerability management. Any of you implement any form of vulnerability management here? Nope. So just to give a, yep. Qualys, nice, perfect. So Qualys is a great example. It's for static image scanning out there, and it provides an entire platform to help you with that. We talked about in the first session that how you can use Gripe to scan your images, and it shows a list of vulnerabilities as well. So basic fundamental is that you scan your images, your code, your infrastructure, you see vulnerabilities, you fix them. That's how, and you integrate your entire pipeline with DevSecOps. So you have your monitoring at every level, your code is scanned, you then build, your builds are scanned, you find out and test, you release. Any point of time, you have multiple scanners in place, and the more you shift left, the less likely to you face vulnerabilities later down the line, and lesser complexity to handle the vulnerability as well. In general, just to give a quick crux is that you as a developer publish an image, you have static scanning in place, there's Trivi, there's Qualys, there's Clear, you have certain tools or management platforms to help you with image scanning or static scanning. At runtime, then after static scanning is done, you deploy your images, and that's where admission policies come into the play. We talked about Kyverno, there's KubeWarden, Open Policy Agent, so they help you at deploy time. And finally, there's runtime security. We already talked about network policy and Falco. One more plug of KubeArmor here, and that's the entire life cycle of what all places you can expect security to be in place, and we'll more talk about where and how in different phases of it vulnerability management comes into play. So challenges with vulnerability management. It was very easy for me to say that you scan it here, you deny it in Kyverno, you maybe protect your applications at runtime, but there are some challenges associated with it. What happens when there's a new vulnerability out there? The tools that we talked about, generally reported about, in the morning we saw a report coming up that my current container is vulnerable to so many high vulnerabilities, so many medium, so many low. But what it does not tell you about is that what if a vulnerability comes tomorrow, and how do you handle that? So those are that's a zero-day vulnerability. To summarize, what zero-day vulnerability is a vulnerability which does not have a patch. So in general, you see a vulnerability, you know that a patch is available, and I will use that patch to fix, and I will be secure. But when a new vulnerability pops up, it does not have a patch. So that's what a zero-day is, and we haven't talked about how to prevent against that till now. So that's why I'm here, and we'll go deeper into this. So any zero-day vulnerabilities people have known here? Any raise of hands? Okay, I gave a teaser for that. Any other? Sorry? SS7, nice. I don't know about that though. So I'll ask about that. Heartbleed, anyone heard about Heartbleed, shell shock? Heartbleed was the biggest one, and that's been the most shocking ever. Log4j, obviously. Recently there was leaky vessels, a lot of things out there. Exe, anyone came to know about Exe? So nice. So that's what the vulnerabilities are about. You don't. So what do? There's a vulnerability out there. You don't have a fix. How do you deal with that? Let's just to explain the scale of the problem. Let's say we take the example of log4j. It starts at November 24. A vulnerability was announced. Generally, a vulnerability is only made public when a patch is available. So on November 24, I think it was discovered on November 12 itself. They spent 12 days to find the vulnerability. And finally, the CV number was released on November 24. But on December 6, they find that whatever patch they created was incomplete. They have still loopholes left. So that was December 6th. They have 2.15 out there, and it's still vulnerable. December 13th, they create 2.16, and it's still vulnerable. They don't know if they have fixed everything or not. So attackers are, so you are from November 24 to December 13, and your application is still vulnerable, and there's no patch out available in the public to fix your application. And December 18, there was a fix. They were happy that our Christmas is going to be good. But on December 28, they find that there's a new vulnerability. They spend their Christmas fixing on this. So if you remember 2021, a lot of people were complaining that our new year is ruined. And that's what this was about. Because after December 28, even if they release the fix, now you as application developers spend the next 3 days, 4 days to take that fix and apply to your infrastructure as well. So take a timeline. It was November 24 to December 28. More than a month of your application being vulnerable. So what do you do about that? And because being vulnerable, I cannot just say that I cannot take my application down as well. So one of the fixes is that you take your application down. But is that feasible? Do you want your business to be down for 1 month or so? That's also not feasible. So that's one part. And before jumping, I'm still not telling you the answer because I want to talk about one more vulnerability. Shell shock. Anyone knows about shell shock? Anyone was here in the same office in the February meetup? I talked about shell shock there as well. So what shell shock was about? It was a vulnerability in Bash. We have been using Bash from the morning to demo many things. Bash is seemingly very innocent looking application, but it had a vulnerability which was being exploited over a scale of, let's say, 1989 to 2014. Anyone can do the math for me. I am not doing that, but over the span of decades. Bash has been vulnerable from V 1.0.3, but people only came to know about it in 2014. Even then, you don't know how many people have already exploited that. But even after the exploitation was made, the CV was made public, it took around 2 or 3 weeks to have the fix released. That too in multiple stages. So because this was such a crucial application, every time it was hard to patch as well, because Bash is a fundamental. It's not your application. Your operating system is there, and releasing updates to operating system is yet another. It's not as fast moving as you can patch your containers. So much more scale of changes and much more difficult to patch as well, to create any runtime patch. So that's the scale. And so the question is, do you just wait for the patch? That's not possible. As I said, if you start waiting for the patch, people are exploiting. People made millions during the shell shock vulnerability. People made millions during the log4j vulnerability as well, because they attacked, they had ransomware attacks, they had other types of attacks. Some did it purely to destroy or corrupt data as well. So you never know. So waiting for the patch is not the solution. Do you have application downtime? Depends. You can try to sandbox it. only keep your other services live, but your vulnerable services down. But that impacts your business. And even if you are not losing millions in terms of your data, you are maybe losing millions in terms of running money that you get. So that's also not a solution. So that's where virtual patch comes into play. And okay, so what's a virtual patch? Anyone knows about virtual patching? So virtual patch is, we talked about patching vulnerabilities. So what patching generally means is that you're upgrading your application, you're upgrading that specific package, and you have a fix available. When you have a fix available, virtual patches, you have a runtime mechanism to sandbox such that the vulnerability cannot be exploited. The vulnerability still exists, but it's not exploitable. And that's seemingly very complicated thing to explain. So I have a demo for that. But that's what virtual patching is about. You don't need to upgrade your application or patch your actual application images. You, as an operations person or a SecOps person, can apply a patch while your developer out there is trying to upgrade your application to fix the vulnerability. So we jump directly to demo now. I will use a few of the tools. One is Kyverno, because we already know about Kyverno, so I will not explain Kyverno. We have Trivy. We talked about Trivy in the first session. It's a vulnerability scanning tool as well, and much like Gripe, what we saw, but it has certain other features as well. And finally, KubeArmor. So we talked about Falco in the morning, where you can audit system behavior. And there was one more part of the flowchart that was prevention. That's what KubeArmor helps with. It can help you prevent things from executing in your cluster, things such as process accesses, network accesses, file accesses, and that are very crucial to especially this vulnerability virtual patch, because now imagine someone is exploiting bash. They are trying to access certain file systems on the internet. Just auditing things does not help you out, because you already know my application is vulnerable. How am I going to know that, okay, someone is exploiting it? How does that benefit me? I need a way to sandbox things out. So the fundamental difference is that it can prevent the attacker when the attack happens. We'll see it in the live demo right now, but that's what the fundamental differences are. So let's directly jump to the demo now. So I have a pod here which talks about, which has a, so I talked about shell shock. So I'm using the shell shockable container, and which has certain vulnerabilities. And it's a simple Apache web server. So we are serving a simple website which does not do anything. It's just a dumb website showing you certain information. And we are using Apache for that, which is a vulnerable Apache. So if I run a scan on it, so I ran a Trivy scan here. Is the font readable for you all? There at the back, not readable? Should I zoom in? Is it readable now? Cool. So we have Trivy scan here, and as you can see, my bash is vulnerable to a CV 2014, which is marked as high. If you remember, there was a CVSS score associated it was 9.8, which is out of 10, which is very high. And if you see the vulnerability itself, it's a specially bash. You can use specially crafted environmental variables to inject shell commands. So basically, you can do remote command injection in your live web server, and that's what we are going to exploit right now. So already I know that Trivy reported me that there's a vulnerability out there. But imagine I am in 2014 right now, and I don't know there's a patch available. So for this, if you see 4.13, the fixed version was 4.37. And imagine I'm in September 26 in 2014, so I don't have the patch version available right now. So what I do is, I'll just show you localhost. So my Apache server loads. So the application is working as expected. And if I try to, this is my vulnerable path where I can see that, okay, it has expected output right now. But now let's try to exploit it. So obviously I am not going to exploit it in web, but I'll show you how we can exploit it using So I ran a curl command on the same path, 8081 cjbin shock me. So one second. The demo gods are not with me. Nothing is blocking. Okay, so very similar example of me accessing etc password D. This is through a web server, by the way. I'm not inside the pod. As an attacker, I could access the passwd file, which is a huge vulnerability. If anyone here has worked in security, people having access to passwd file is very risky, and we could exploit it through just an env variable, which is the agent variable here. So what do we do? Should I just take down my application at this point? But I don't want to do that. What I'm going to propose is, we'll see if we can. I talked about the DefSec model. So if I see, I have deployed a trivia operator here, which creates a vulnerability report saying that I have a vulnerability in my, say, pod shell shockable, and it has so and so vulnerabilities. I, as a security person, just want to deny bash from executing in my cluster because my application developer has not yet created a patch for that. So what do I do? Should I just start applying? Should I just wait for that? But I cannot wait for that. So what I've done is, I've created a Kyverno policy here, which detects whenever a new vulnerability report is created, I check what is the name of the pod object and what's the name of the vulnerability. So I, as a security person, know what's the virtual patch out there. That's an assumption, or someone out there. So we at KubeArmor maintain a database of vulnerability versus virtual patch as well. And there are tools out there which do keep this database of virtual patch to vulnerability mapping. So I match that. If the vulnerability report says that it is vulnerable to CV2 2014-6271, I generate a virtual patch saying block bin bash, and seemingly okay thing to do. So what I'll do is, I'll just apply this policy now. What it did under the hood was, it realized that there's a vulnerability report out there, and it generated a KubeArmor security policy saying block CV 2014 in pod shell shockable. You see, it was created 13 seconds ago. That was not me. It was automated by Kyverno. So anytime any new pod is deployed with this vulnerability, it will automatically create a patch, virtual patch for that as well. So let's try to exploit this out now. So if I still see, I can still access the web server as expected. But if I go ahead and try to access the vulnerability, which shell was it? Yeah. So I try to access cat etc password d, and it starts saying me internal server error now, because it was not able to execute that bash, and I would have received, I'll just open logs for my help. So if I try to access it again, it shows me alert that KubeArmor blocked the CV. Apache was trying to spawn a bin bash binary, which it is not supposed to do. And I have all the other context for the context for further forensics. So just preventing the vulnerability is not enough. I, as a security person, need a lot of context to help me out with further analyzing where and who is exploiting this. So, yep. So in short, vulnerability was prevented. Yeah, any claps for that? But do I just block bash? Is it not impacting my application? In general, this application was not supposed to do bash. So you could just say that why include bash in the first place? But if we were doing that, we would not have so many security talks out there. But I'll tell you one more thing. So this is one example of patch. Because in general, there was no way in bash to prevent that exact function call, because that's how bash internally works. You, as a system level engineer, you cannot handle that vulnerability in the first place. But I can scope it down. What I'll do is, in general, this page was supposed to return me that regular output that I saw, but it's not doing that. So what can I do? So I have one more policy to show, which is I understanding my application behavior and creating a policy out of that. So in general, I have allowed CGI bin, which is responsible for that regular expected output, a bunch of recommendations to do that no one should be able to modify your etcd bin directory, user s bin directory, so that your application themselves are not like no one modifies the application to start exploiting things. And finally, I have a whitelisted set of binary that, okay, Apache is supposed to run, bash is supposed to run, and shockme.cgi is supposed to run. So now my application behavior is to actually let these run. You see, I have allowed bash at this point. We were trying to block bash, but we'll try to exploit the vulnerability now. It did not return me anything here because I tried to execute things and it saw that bash is trying to access cat and bash was trying to be spawned. I mentioned that only Apache and bash should be interchangeably spawned, so this was not allowed. But if I try to access the web page now, it works as expected. So now at this point, I have patched my vulnerability due to a zero trust policy. At the same time, my application works as expected, so I don't have any downtime. So that was the end goal for me to show. So we have a mechanism now that as soon as there's a new vulnerability report created, now a SecOps person can create a virtual patch for that. You might ask, where does that virtual patch come from? That's still like out in the forum. We as vendors create those virtual patches. You as a security person can create those virtual patches. It needs to be community work, because when vulnerabilities come, it's not like whoever is trying, like me just discovering the vulnerability does not guarantee that I know how to fix it. So it comes from the community, but this has much more faster time to patch it because it does not go through that entire life cycle of you asking your application developer to create any upgrades and that rollout of how it goes. You do it at runtime, it's detected at runtime, patched at runtime. So it scales down the time to much more like faster feedback. So yep, that was about the talk.